right. So we'll talk a little bit about open source. We ran a similar setup last year with an Open edX platform, which is also an open source MOOC, so massively online kind of content platform. So it wasn't actually an LMS. It was more like a courseware platform where people can distribute videos and kind of a course material to a massive number of participants and collect the usage statistics based on that. So those two projects are very similar. Moodle is an older, slightly differently written project, but both of them are open source. And when I was redoing the slides for this year, I actually reused a number of slides from last year's presentation because those two tools have a lot in common. There are some differences though, and it will be quite interesting to see how those differences work out with the teams that we have this year. So first, let's have a look of what open source is. So what is open source? According to Google definition, we have a piece of software which is distributed together with the source code. What does open source mean to you? What do you feel an open source project is? Yeah?
That you can look at the source code for that particular piece of software.
You can change it.
You can modify it, you can view it, you can modify it. What else? Is it for free?
Doesn't have to be.
Doesn't have to be. So the business model doesn't really relate to either software is open source or not. But do you have examples of open source projects which are paid?
I know there are some open source projects that are paid for support, but maybe not for
the code.
For the code.
Yeah, so what does it mean open source then? So you can view the code, you can modify it, but then if you modified it, can you then resell it?
Depends on license.
Exactly, so there are different models, right? So there are some different models, but even though open source is not related directly to a business model, it tends not to have a business model where the source is sold as a commodity. The reason for that is that most of the projects kind of want to have the source which is written by contributors kind of feeding back to the original project, in which case some open source licenses kind of restrict you of what you can do with the contributions that you're making to an open source project. And most of them rely on the fact that the contributors then contribute to the main project and it continues to be open source as a whole. All right, do you know this guy? Yeah, Linus in his early 20s and his famous blog on the newsgroup. I'm doing a free operating system, so have you seen that before? It's one of the most famous open source projects in the world. So a 22-year-old at the university starts a small hobby project, which became 20 years later quite a huge phenomenon, right? So we've been celebrating 25 years of Linux because on 25th of August, he kind of posted this famous newsgroup post trying to get some people to test his little kernel that he wrote. And he sort of started quite a change in the world because of his hobby project. And it's one of the kind of largest and most successful open source projects in the world. There are two reasons why I'm bringing that up. So one reason is that it is the biggest and most famous and so on project, and it was started by a 22-year-old, and that it runs kind of on everything, starting from Android phones to big data centers and so on. But the second reason is that the Moodle project is sometimes compared to Linux. And the original contributor who started Moodle was kind of working like Linux a little bit. So he had good technical skills. He had sort of a good circles of friends, and he started the Moodle project. So we'll talk a little bit about it in a minute. So some of the open source characteristics are that the users are sort of put in control. They can view the source, they can see, investigate how certain things are kind of written, and they can change them, right? When the software industry was starting up, in some countries, for example, in Poland, it was illegal for a vendor to lock somebody into their solution, right? So, for example, if I bought a Microsoft 3.1 license from Microsoft in Poland, I could modify the code of that software to suit my monitor or to suit my printer if that support wasn't there in the first place, right? So in the original licensing agreement for Microsoft products, for example, it was written that, of course, Microsoft owns everything, and you don't have a view to the source code and so on. And some people were reverse engineering the Microsoft kernel code to provide some changes to their printers or to whatever devices they had, because Microsoft was not supporting that. And Microsoft was trying to sue them to prevent reverse engineering of the code. And the Polish legal system said, no, it's legal. I mean, somebody bought something and they cannot use it with the hardware they have, and they should be able to do that. They should be able to use it on whatever hardware they have if they already bought it. It's their property. So even though Microsoft was not redistributing source code, reverse engineering code was legal. Of course, because of lobbying and because of some market pressures and so on, that situation somewhat changed. And you kind of are writing off all your consumer rights to a lot of services and a lot of products these days. But this sort of mantra, this philosophy that you are purchasing or investing into a tool or some product and then modifying to suit better your needs still remains, especially in the open source movement. The second area where open source is very important is that you can verify of what you're actually running. So a lot of security conscious people or data privacy people would like to know what the software is doing behind the scenes, so they know whether there is certain data leakage or what the software actually does. And a lot of security is done by opening up the implementation so everybody can verify and test if they have vulnerabilities. So we do have quite a big progress because majority of security solutions are not based on hiding things, but to the contrary, by opening them up and letting everybody to try to break them, and then making sure that the solutions are actually secure and vulnerability proof. In theory, it works really well. In practice, of course, we did have some major setbacks with open source projects, like with the OpenSSH SSL library, for example. But that doesn't undermine the model. I think the model is correct. It's just that, as with everything else, there are software bugs which sometimes are difficult to spot or difficult to detect. But eventually, they are detected, and then vulnerabilities are fixed. So you can verify the code, you can extend it, and you can customize it to your own needs. What else would you add to that list? What else do you think open source brings to the table which the closed source model doesn't? Rune mentioned that in the previous lecture. What do you think?
The ability to have contributors around the world.
Exactly, this kind of globalness, right? So a lot of open source projects are very diverse. You have contributors from all over the world participating in a project and bringing certain perspectives, certain user requirements, or certain use cases which otherwise you wouldn't think of. So a lot of open source projects benefit by being open and extensible and global, in a sense that people from different cultures can contribute, both in terms of usage scenarios as well as in terms of development. So let's have a look at the development side. We have this classical bazaar versus cathedral kind of models, right? So there is this famous book, Cathedral and the Bazaar, which kind of dives a little bit into the theory of how software development can happen. So we do have more planned and scheduled sort of software development processes, or we have more sort of a self-organizing agile development processes. And we also have certain hierarchical sort of organizational structures to produce software, and we may have very flat sort of models. So historically, looking at the big open source projects, we see that they tend to lean towards, bazaar and self-organized, as well as towards more flat structures. And by flat, typically you have two levels of hierarchy. So you have a general public, which can issue bugs or inject some issue into issue tracker. And you have the kind of second layer, which is people who gain certain credibility and can manage the process. So they tend to know what's going on, they tend to know where things are, and they tend to be the decision makers whether something gets injected into the code base or rejected, right? So what's accepted, what's rejected, and whose contributions can go in, or which contributions need to be reviewed further. So this kind of a two-level structure tends to also have one or two people who are the kind of dictators who override everybody else. So whatever the decision of that person is, that kind of stays. And you see that with Linux. So whatever the officers say, that will stay. And then you have a number of people who review changes and adopt things into the kernel. And then you have the broad majority of contributors whose contributions kind of go in, but have to be filtered through the quality assurance and making sure that that the process works, that the process doesn't get into a kind of a chaotic, non-converging development. So that this kind of in general of how the characteristics of an open source project look like. And you've mentioned that you had some experiences with contributing to open source. So how was that? How did it work, and how it compares to what I just said?
Well, for me, it was, like you said, it was kind of flat organized. I was the public submitting a pull request, and there was a few other people that managed that pull request, did the certifications, reviewed it, and so on and so forth, and then they accepted it. And,
yeah.
That was kind of.
Was it similar?
Yeah, there's usually just contribute to small projects. And there's like one guy most often that merges things in, and just otherwise it's flat.
Yeah.
But he has to accept it.
Yeah, exactly. So typically, my experiences were similar. So you typically can contribute issues or patches, but they will not be accepted automatically. There will be some decision making which kind of happens. Yeah.
In some projects, I would say that I saw a three-level structure, maybe more, because it was users who can submit issues, like just that bug occurs or something. Then there are people who can make merge requests for fix these issues, and there are people who has right access to repository, and then there are some owners of this project, like dictators. So it's like the users, developers, and people who has rights to right access to repositories.
Yeah, so I kind of bundle the non-right access users into the single level. So those are the users and developers who can contribute issues and patches. and then those are the ones who have the right access and make the actual decisions. But you're right, it might be separated into sort of 3 levels. So how is the communication happening? So with your projects, how you are communicating with the rest of the team?
GitHub issues.
Yeah.
Same.
Yeah. So just by the issue tracker, basically.
Yeah.
No mailing list?
No, it's using the issue tracker.
Well, I was contributing in GNOME, and they use an email lists.
Yeah.
But yes, it's still most likely it will be issue tracker.
Yeah. So the main cornerstone kind of a tool is the issue tracker for all of them. But some projects, especially if they are kind of more bigger and kind of longer running, a mailing list is typically associated with it. And it's for 2 reasons. So one reason is that it allows people to kind of discuss a little bit more. So you can have like issue trackers tend to be very succinct, like very small amount of text goes in. You have descriptions and so on, but it doesn't allow you to sort of converse on an issue too much. You're sort of down to a point. Whereas the mailing list allows you to sort of explore a little bit more before the work commences. So the projects I've been working with, they all had a mailing list, which was sort of the place to comment on things and to raise certain issues and then accept or reject certain proposals. So it was the place to kind of discuss. And almost all projects I know of also have an IRC channel to kind of an online sort of discussions. It was the same with yours?
Yeah, well, like most projects were just issues on GitHub, but I was working on SDL where they have a combined mailing list and forum. So what you post on forum, get on mailing list, vice versa. And they also have IRC, but I didn't do stuff.
Yeah, so IRC is one of those weird things because it's not strictly for development, it's for just hanging out, and when people were calling, we're kind of hanging out and chatting. So it wasn't as semantically rich, as you would say, but kind of exploratory channel of communication. All right, so let's talk a little bit about Moodle. So what is Moodle? Well, you may say it's a learning management system, so kind of LMS, like a Fronter. You could also say that it's a courseware platform, so you can distribute your course. I mean, you can develop your course and then distribute it to a wider audience using Moodle, right? So you don't need to keep track of the student achievements in Moodle for your university. You can do it. You can use Moodle as a kind of a distribution platform for your courses. So a courseware platform, and of course it is an open source project. So one article I put into slides, and you can sort of read it later on. It broke it. So let's see one more thing. Yeah, it's just taking time. All right, so about a year ago, the main kind of contributor wrote an article explaining what Moodle is. And he argues that it's not just an LMS, that it was never really intended as an LMS. It is an LMS, but he kind of makes a claim that it's sort of a superset of various things of what LMS should provide. And then if you check their vision, they sort of list a number of things which kind of go a little bit beyond a normal LMS system. So they want to be quite comprehensive in the feature set, quite ambitious, and they want to offer solutions both for course delivery as well as the kind of a student management. So you may think of it as kind of a superset of what LMS and courseware platforms and kind of massively online platforms could deliver to students. So it is quite large, quite complicated system. So they say support teachers, support learners, everything, support, like integrate everything that may need to go into a course to be open in every way, although the delivery and the content that you describe can be fully private. And then support all possible devices, so mobile devices and web-based framework, have the very flexible tool set, and be scalable to different sizes of organizations. So pretty ambitious vision. So the history, the project started before 2002, as I was saying, written by computer scientist Martin Dagemas, and he is an Australian, spending most of his time in Western Australia, and when he was working on it, he was inspired by his own sort of experiences. So he spent a lot of time living in a very rural places in Australia, remote, and his only way of learning was through the use of internet and through the things dropped by the plane. So he was kind of studying offline most of the time. He didn't participate in a kind of a traditional university. So at the moment, he's still the main kind of driving force behind Moodle, and there are around 30 full-time developers working on it from headquarters in Australia. And we've looked with Simon, and there were around 350 contributors on GitHub over the last few years. So it is quite a big project. That's him. And if you check him out, it says he was the main original contributor to Moodle. But if you check all the contributions, he is still by far #1 in terms of GitHub commits to the project. So he maintains, his lead, I would say. All right. So Moodle is open source. It can be used for extending and modifying and adding new features. It can host a number of plugins and can be tailored to a particular course needs. It can be run on different infrastructures. You can run it from your server at home, or you can use it at the university. A lot of universities deploy Moodle as their de facto LMS systems. And in fact, you can run Moodle with the Blackboard backend as well. So you can integrate an existing LMS and use Moodle on a front end for delivering the coursework to students. And then you can extend it and modify it, but Moodle doesn't own anything you do with it, right? So if you deliver a course, or if you develop a course and deliver it through Moodle, or if you're collecting data through Moodle platform, this is all yours. You don't need to share it, and you can do private deployments of the software as well. So it is kind of very flexible model, I would say. Yeah, so as I was saying, the universities and organizations control the content, and you can, whatever the software licensing model is and how the software is being developed has no bearings of how you use it and what content you do with it, right? So the content and the tool are sort of separated. And also, because it's open and because you can inject a number of things, it's kind of an ideal research tool, as well as the Open edX platform. So you can collect a number of data sets and indicators from running a course on Moodle, and then use it to inform you of the certain indicators of how things are kind of consumed and how things are done and what our students are doing and what progress the students are at some point. It's not unique to Moodle, of course. So Open edX has the same, and if you think of any LMS system, they all integrate some of the indicators that can guide you through the course, guide you as a student and guide you as a lecturer. But what's different is that you can kind of modify it, and you can inject, and you can automate some of those things yourself, both as a student and as a teacher. So that kind of opens up certain opportunities for research and for deployment. All right, so couple of words about the technology behind. So you have to go back in time and think of, year 2000 when this person, Martin, is coming up with the idea for the LMS system or this kind of a courseware platform, and what tools are available at the time. There is no Node.js yet. There is no Mongo. There is MySQL. There are relational databases. There is the web, and
PHP.
what?
PHP.
And there is PHP, right? So here we go. So it's written in PHP, right? So the web core and all the services are written in PHP, and then they are supporting mobile, and they use the kind of modern languages for the mobile front ends. But at the time when the software was written, there was no even a web framework for PHP, right? At the moment, if you are starting a new project for PHP, you have those nice modular frameworks, and you could write sort of a modular system with one of those frameworks. But back in the day, there were none, and they just had sort of a scripts. So a PHP sort of a request was handled by a PHP script, and a page was generated, right? So request, response, request, response. No fancy middleware, no fancy compartmentalization of building blocks, no sort of modular design. And that stayed until today. So the whole software is kind of a collection of simple scripts, even though the complexity of the software would make you think that that would never work, right? It's too complex to be just simple collection of request response scripts. And one new thing that we have in web development is this clear separation of the business logic from presentation layer, right? That's what I like with the modern frameworks, that you can completely separate logically of what the system is doing to how things are presented, because then you can re-render or repurpose the presentation layer without touching the logic. But with PHP, especially with the early days PHP, it was bundled together. So you make a request, and the PHP script generates a web page for you. Now, if you want to handle the same request by the mobile device, well, you have to have a different script. But even though you change the presentation layer, the logic might be the same. So this different script is redoing the same part of logic which you've already been doing here. So the separation of the UI from the logic is kind of essential, and that's what they are doing now. So even though it is a kind of collection of simple request response scripts, they try to separate of what has a UI and it goes into so-called UI layer, and what is kind of related only to handling logic, and it goes to libraries or scripts which just handle the logic of the processing. And if you do that, then you can reuse the logic to render the UI for the web client and render the UI for the mobile client. But as I'm saying, it is kind of evolutionary developed, and it hasn't been designed, and it hasn't been following any sort of a web framework designs per se. So this is to contrast what we've been using last year. So last year we've used OpenEdX, and OpenEdX is written in Python, and they're using Django as the kind of underlying web framework. So it's very nicely structured and very nicely organized in terms of architectural design. And it has very clear separations of modules. So you have certain modules which handle particular logical things and particular visual things. So the engineering effort and architectural effort which went into OpenEdX is by far greater than the one which went here. But at the same time, we don't know whether the complexity related to those two projects kind of follow the same pattern, right? So it might be that even though the other system is better engineered, it might happen that it's more complicated. And this one, even though it is not as heavily engineered, might be easier, or vice versa. We don't know that. We will kind of learn this year, what happens. What we learned last year was that even though all the indicators suggested the other open source project being kind of very nice and very modular and very easy to get into, students actually had a little bit of a problem, especially that they couldn't get the testing environment run on Windows. It turned out that even though theoretically it should be possible. In practice, it only ran on Linux instances, and people had to use kind of a virtual machines and background images to run it. And they spent, I don't know, 3 sprints, possibly like the first 3 sprints, just getting to know the tools and getting to be sort of working. We will see how it's gonna go this year, and judging from the documentation and judging from the sort of setup that Moodle is using, it should be easier in fact, right? So I think the designs are sort of simpler, and you shouldn't really learn of how you should build complex web-based systems using Moodle, because it might not be the best way of building very complex web systems today in 2016. But having said that, it works and it fulfills its duties, and it might actually be easier to contribute because you don't need to get your head around a complex architecture. You just need to get your head around a couple of scripts, which sort of you fixing or helping with, and get that sorted, which is completely independent of anything else, because you don't have sort of a necessary kind of a deep cross script dependencies. Yeah.
And if anyone is up for the challenge, there is a proposal to port it to Node.js.
Yeah, that's right.
Be their guest.
Exactly. So of course the modern web developers and developers in general are very keen on Moodle, but they say, yeah, PHP with no web framework, I mean, it's a nightmare, right, to work with. We will see. I mean, there are some proposals to port it to Node.js and kind of shift it to a more modern sort of tool sets and modern designs. So in theory, it should be easier to make contributions or patch things and work with it. But well, time will tell, and we will learn more using this course. So there is kind of a detailed architectural documentation if you go to Moodle, and you will see quite a comprehensive well-written, well-structured documents, and how things are organized and how things follow. And then you can also see quite a detailed, just by looking at the guideline section of how many coding guides and how to write tests, how to create patches, how to do things. They are quite a well-organized bunch, and they sort of provide a necessary help for you to sort of jump into the development and contributing to the project. All right, so I think that leads to Rune's part about the tasks, or should I mention?
Yeah, just go to it.
So after the initial discussions, we were thinking of 2 potential models. So one model is that, of course, there is a Jira-based issue tracker, and there are some open challenges, like open tasks for now, and there are kind of a more long-term projects, like Rune mentioned, for example, porting to Node.js from PHP. And some of them are smaller, some of them are larger, but you can find one and kind of get yourself involved and then contribute at supporting that feature or fixing those bugs or whatever you kind of get under your belt, right? So there is a community which works on certain things and plans certain sprints, and there is quite a large backlog of tasks which range from a couple of hours of fixing to longer. And then one model is that you kind of include yourself into the development process and start helping with some of those tasks which are defined already in the Jira backlog, right? So you can either use the existing tasks which are already specified, or you can sort of follow up on the wish list, or those are more sort of blue sky extensions or modifications to Moodle, which then you would have to split into individual tasks and then contribute, right? So that's kind of a general area where we see you sort of engaging with the kind of global community and helping out. The other aspect is that you may work on something which is kind of separate in a form of a plugin or a form of extension which plugs into Moodle, but doesn't relate to the community at all at the moment, right? So you may initiate some new feature or new feature set or new extension to Moodle, which you can work on individually. Of course, you can advertise it, and of course, you have to rely on the support and the backbone which Moodle offers, but your work in a way is a little bit more independent from the rest of the working. So it is unlikely that you will be working with other developers on a feature that you just came up with. It's more likely that you will be working as a group on it and then contribute it to the Moodle project as an extension. If you choose the first model, it's very likely that you will be working with other developers who also were kind of contributing to that part of the project. So if, I don't know, just let's pick an example that you picked something about internationalization to Norwegian, and there are some other Norwegians who are working on or contributing something, you probably would work with them, right? So you would not work in isolation, you'd be working with other developers or contributors from elsewhere who were sort of interested in the same space, or let's say mobile Android client, right? You might be extending the mobile Android client, and there are existing developers who already work on the mobile Android client. So you would be working with them. With the second model, you would be working more likely alone as a group and contributing kind of a larger piece of functionality, which is independent of the existing backlog of tasks, which offers something that Moodle doesn't offer at the moment, right? That's kind of a rough summary of those two initial models that we were thinking. We would like your input, of course. So the first sprint is for you to get to know the tool, get to know what Moodle is about, how it is organized, how it looks architecturally, how the Jira backlog looks like, what tasks they are. So, you know, have a look around, install it on your workstations, compile it, get it to work, and then we have another session where we actually discuss exactly what you would be working on and whether you'll be working with this model 1, where you pick some of the tasks from the existing backlog, or whether you'll be working with the second model where you kind of contribute an extension or a plugin to Moodle. Last year with OpenEdX, we defined the tasks for the students. So we asked them to provide a couple of extensions to the OpenEdX platform. And the functionality turned out to be quite trivial, actually. So once you get your head around how it is structured and how the build process works, actually coding the solutions was the easiest, actually, for the entire projects they were doing. So they've added some extensions like voting up, thumbs up and thumbs down for the video lectures. And we had also the questions with confidence intervals, I think. So adding kind of a confidence. Do you remember the exams with Simon from game design where you can answer a question and say how confident you are with your answer? So we've added it to kind of our quizzes and tests, online tests, which OpenEdX supports. So the students were adding the confidence intervals. So that's how it ran last year, that we designed the tasks for the students, and then they sort of contributed the plugins which fulfill those tasks. But with projects like that, we feel that it might actually be also quite interesting and quite engaging to work on the backlog they already have, to kind of get yourself fully immersed in a project which already runs and it's quite big, and you can sort of help, you know, put your name on, you know, on the wall over there, right? So as we were watching this, yeah, this one. You know, you can put your name here by fixing issues and solving things. And if you scroll down, I mean, it's not as if everybody is doing thousands of commits, right? You can get to just having few, right? 3 commits, right? But it's already, you know, you've already contributed. You've already helped something to become better. So you can see that there is a number of people who just contributed a single patch or single commit. Yeah, by the way, for the Linux kernel, it is kind of an exponential sort of curve. exponential curve. So there are very few people who contribute a lot, and there is like thousands of people who contributed one single patch, right? But that's very valuable. Like those thousands of people contributed thousands of patches, even though they did just one, right? So it's kind of in your hands in a way, right? We don't have a fixed sort of design at the moment. We will talk with you and discuss with you what's best. And you have the first sprint, the first 2 weeks to sort of get to know the tool chain, the environment, and the setup, to sort of get your head around a little bit of how it works and what might be the best way to contribute. All right. Thank you. Questions?
If we will take this first approach by fixing bugs and implementing small tasks in backlog, how we should then communicate between team? Because probably there are a lot of tasks are just for one person, and we would be just not like a team, but more like a set of developers, and less collaborating in between us as a team, but more just contributing to the project.
Yeah, that's a valid point. So I would imagine that even though you may pick, let's say it's 6 of you, you picked 6 tasks, and you're kind of working with it, but within the team, you can share your experiences. You can share, what sort of problems you had deploying it, or what sort of problems you had setting up the environment, and so on. You're still a team, right? You still talk with each other, even if you have separate tasks. If you were to work on a project, let's say I gave you a project, you wrote a number of tasks in your backlog. Each of you would pick one of those tasks, and you would be working on each of those tasks anyway, right? And you'd be all working on the same project, but independently. You almost never work. Of course, we sometimes encourage like team programming and pair programming, but most of the time you actually code alone on a single task, right? So you will assign yourself to a particular task, and then you would kind of do it. So with the normal projects that we run, the process of setting up the project and splitting things into tasks, it's done by you as a team. In this case, you have a global team, which already did part of it, and you kind of becoming part of the team. But you as a team here you are also a team. So there is no really a huge difference, right? Whether 6 of you take one single task and try to do it, because you will still have to split it into tasks for each of you, right?
I still feel like it's more of a management process will be if we'll have one task that we all work on, because we have to decide on some architectural decisions and stuff. And in the first case, we maybe will have some decisions, but probably we will discuss them with other contributors. Probably. Yeah,
we just had the discussion with Rune and Simon before that, if you pick a task, you have to judge how big it is, whether it's a single person task or 2 people task. And you may have to say, well, let's take those 2, and this 2 have to be done by those 2 people, and those 2 by those 2 people, because those are quite big. And this one is quite small, so 1 person can do it. You still need to do a little bit of this management and task allocation and weighting how difficult they are and so on. So even though you do have a big backlog or you do have a big wish list, you still have to do this type of micromanagement of the project on your own. Yeah.
And some bit of reference to the mobile Moodle and quiz extensions. I don't know, Moodle and blockchain, but that's a bit too big of a piece to...
Yeah, so that one is one of those in the sky kind of projects, long term. They would like to have an extension to Moodle which validates kind of across credentials, across different Moodle distributions using blockchain technology. So you have sort of a way to confirm that you've done certain tests or you've done certain accreditations in particular Moodle instance based on that particular institution, using Moodle as a platform, and then cross-validated with other Moodle institution. So in theory, it sounds nice, but I don't think there is any implementation at the moment. You would have to start from scratch, and it would be quite a push to get something going in the time assigned for this project. So it might be too big to have something productive in that time frame. But yeah, those are just ideas, right? So if you have a team which is kind of strong in mobile, you can say, yeah, let's help with Android development, or let's help with kind of a mobile client more. If you want to do something with web, you can dive into the main kind of a core setup. Yeah. Or you can add, reminders on the Google Wear for the watch, so the watch, hooks up with the Moodle platform and announces you whatever deadlines are coming or tests are coming, so you have sort of a reminder on your wrist. We have one Google Wear watch you could play with. Yeah, it's kind of up to you, like what sort of scope you feel is possible to tackle. And of course, we will talk with you about that as well. So, yeah.
Back to the question that I was having about whether these are individual projects or group projects. I mean, if you think about the headquarters in Australia, 30 developers, they're obviously also a group. So I think what you should do if you're a group is that you should not consider each one individual, but look at the set of tasks that together would be kind of a next person or that jointly would make sense to take together. Then you will have the same discussions that you will have in any group. So it's not just one picks one, but lift it up the level and say, okay, now we would like to move this piece of software up a little bit in the next sprint. And then you choose these are the set of features that we would like to do in that sprint, and then you reassign tasks on the whole group to see that you can actually lift the whole upper level.
Yeah, exactly.
As the headquarter team will do.
Yeah.
Take care. So besides all the individuals, the headquarter team will have a kind of a long-term roadmap and make sure that jointly they bring the software up to where it wants to be.
At the same time, I feel like if we have a separate project, we can make more decisions by ourselves without interacting much with other contributors. But if we will take from backlog, they probably have some view on how to implement these features and how they see them. So we probably will have to interact much more with other contributors in that scenario than if we will take like our own approach, like some sub-project.
I would think so, yeah. So I would think that if you pick the approach of extending Moodle by some sort of functionality that is not in the backlog at the moment, you would be a little bit more independent, and it's a little bit more up to you. You still have to follow the coding standards, you have to still follow the guidelines and code against the modules they already have, but you probably have more freedom. If you follow the existing backlog, you're probably right. You probably be a little bit more involved with the other team members and so on. But that's what we expect. Yeah. Yeah, last year the students didn't really interact with the community that much. They only used the community for troubleshooting their problems. So why it doesn't work? Why, and there were not a lot of questions of how to do something, because most of those questions were actually quite well described in the guides. And as I said, the modular architecture of the other system made it easy to contribute, because you know from which to pick the pieces and how you have to put it together. So on the technical level, it was not a very big challenge. It was a little bit of a challenge on setting things up and getting to understand the overall architecture, because it is both of those. This is also quite a big project, and they require a little bit upfront investment of time to understand of how things are and how to set up your own environments and so forth. But
which is kind of an added value here from a learning perspective, is that so far, I guess most of the projects we're working on, you have started from scratch and developed all the code from the very beginning. Now you have a code base.
Exactly.
That you need to hook into.
So that's one of the main objectives here, that you don't starting a new project afresh. Oh, let's design something and let's build it from zero, right? You have to work with an existing code base, which is non-trivial. This is quite a big code base. And even if you're working on your own feature, you're still working with that code base. You have to understand how to plug in your features to to existing code. And we want you to have that experience. We want you to work with an existing large code base, because that's very likely what's going to happen once you leave the university. You're not going to go somewhere and start something from zero. You most likely going to work with an existing code of some sort.
And also, if a project is so large that you would like to solve it in a global sense, then it is obviously some existing code there, most likely when you start, because you start small and then you scale it up, but the point where it gets global, then there's all the kind of the code that you need to get some external into work on.
That's right.
Okay. So you know what to do till next time?
Till next time. So should we prepare a presentation just for the papers, or what? I didn't understand that part.
So that's one thing, is prepare for the papers. And secondly is that you need to set up the tools. So you need to have a running production chain, and you should report on what the plans for next sprint. The next sprint, or the first sprint, will actually be to deliver, which means that you need to decide on status for initial investigation and plans for sprint 1, which means that you're already pretty much chosen what project and what tasks you will solve in that sprint. So this is not, it's not a demo. Of course, you haven't developed anything. It's not a retrospective, but you will have the plans for sprint 1, which means that you need to decide on what the project should be. And that will be interacting with the hospital Simon and choosing which project you would like to work on, and then start breaking it down and have the plans. Because that's, next time we meet, that's the start of the first sprint. Then you need to know what to do in that sprint. So there is quite a lot of work on, and to be able to estimate, you need to already have the system up and running and been playing with it, testing it. So there is quite a lot of work also on the project here, so that you can both estimate and you can actually be developing in the next sprint.
So next Friday, there's a time slot for this course.
Thursday,
not Friday. Thursday, on 9th of September, or 8th of September.
Shouldn't be until the 12th.
There, 12th. Yeah, there is on 12th, on Monday.
Okay.
There's also on Thursday.
So the Thursday is probably a mistake.
Yeah, I didn't see that. I'll check on that. No, there should be just Mondays every 2 weeks.
Yeah.
If there's anything else, I'll ask the, what you call it, the dictator of the
Timetable,
calendar.
yeah.
Timetable
dictator?
Yeah, that's wrong. So there's nothing until 2 week sprints.
2 weeks. So then it's
Mondays.
There's a mistake in week 36. Yeah.
It's probably double. I mean, because last year they were Thursdays, they probably put up 4 Thursdays or 5 Thursdays, and then when I asked for Mondays, it didn't remove the 5 Thursdays, I guess, because last year we were running them on Thursdays, because that's what the Finland group could have, and maybe they just used the templates when I asked for something else, they didn't erase the ones. Yeah, don't worry about Thursdays. I'll ask them to remove the Thursday appointments. Okay, and it would be good if we get to see you before next Monday. Then you talk to us and keep us a little bit up to date on what you're thinking and what your plans are. Very
If
good.
you are comfortable, we can decide on some meeting time, also weekly or fortnightly, whichever is convenient for you. Just keep in touch.